right, permutations. Permutations. Here we go. This was yesterday's quiz, so let's get into it. Please remember, I've started to put due dates just on the quizzes to try to declutter your schedule. If that's not a good idea, if you'd like me to put the whole lesson on there, I gladly will. Okay? All right, sorry about that. I had some messages coming in and I just had to respond, so I paused the video. Permutations. Yes, here we go. What is the value? Okay, this is great. This is a different notation, but I discovered something that made me super happy. Let us go to Desmos Scientific. Yeah, I think so. I can't remember already. Cool. Here we go. Desmos Scientific. Well, that doesn't look great. ABC, no. Function. NPR. National Public Radio. Okay, we read that in choose R. This is for permutations. You've guessed it. This is for combinations. There's a little bit of a difference in the formulas, and we can talk about those in a second too. So I think we will just use the calculator and I will show you the equation so you understand what a factorial is. This says 4 choose 2. That means you have a group of 4 items and you want to know how many different ways can you arrange 2 of them. So we'll go over here to our calculator. We'll go back to main, 4, 2, enter, 12. But what's happening mathematically is we have this formula in PR. I'll write it in PR is equal to n factorial over n minus r factorial. Oops, parentheses inside right here. Factorial, so we would do 4 for our n, 4 factorial over n, which is 4 minus r, which is how many we're choosing, factorial, which equals 4 factorial over 2 factorial. Now, factorial isn't scary. It's actually a very simple function, kind of like addition, subtraction, multiplication, and division. That exclamation mark symbol merely means starting with whatever number you have, so 4, you're going to multiply it by 1 less, times 3, times 2, times 1, until you get to 1, and then you stop. Same thing for 2. So this would be 2 times 1. That's what that equals. So just 2. And 4 equals 4 times 3 times 2 times 1. The neat thing is you could do 4 times 3 times 2 factorial. See what I did there? I broke it up. Over 2 factorial. And then just like every division, those simplify and you're left with 4 times 3, which is 12. Okay? So that is the hand calculations to this new equation, this new button on our calculators that we get to see what happens. And again, that means there's 12 different ways for 12 different permutations to say have 4 of something and arrange 2 of them, right? Right? You take this one with that one. Anyway, we can talk. I do encourage you to take some time to visualize because it will help make these concepts more concrete, but that's the calculation. So we did the calculation. Hey, there's 12. That's how many permutations there are. Let's keep going. All right. Woo! 9 choose 9. So we'll go use our calculator, but I want to remind you this means 9 factorial over parentheses 9 minus 9. Remember, n minus r factorial, which will become 9 factorial over 0 factorial. We can't have division by 0. It's not, because 0 factorial actually equals, we define it to equal 1. Okay, so if you see 0 factorial, it's just 1, which becomes just 9 factorial. Let's go play on our calculator. 9. There's no, let me see, is it here? Yep, there it is, 9 factorial. There it is. So you can do 9 factorial. You could still do this one, and you could still do in NPR 9 times 9. And they're the same. Okay. Almost. Gonna keep going. Use a permutation expression to solve. 8 swimmers are competing in a race. How many ways can the swimmers fill the top 3 spots for the fastest times? Well, now you have to decide what you're doing. Okay, so remember, you have 8 swimmers, and you want to know how many for the top 3 spots. Well, N is always the total you have to choose from. And then R is always how many of them are you choosing? And then the permutations tell you how many permutations, how many options there are, right? So if you have 8 swimmers and you want to choose 3 for the top spots, you would do N is 8, choosing R to be 3. You can use your calculator or the factorials, and you'll get 336. Wow. Pretty cool. It's a lot of different ways that they could compete and win. That's crazy. Like, that's a lot of things could happen. Now, it's a little bit different because with data, you would kind of know who is going to win. If you've ever been to a horse race, they do things like the odds. You get a little pamphlet and they start to tell you the odds that they have. There's some math involved there. But again, it's based on lots of things like their data. Sorry, I don't know if you have that invisible hair. All right, a minute left before I have to go, so use a permutation expression to solve. In the class of 35 online students, how many ways can the students give the first 4 presentations? Okay. There's 35 students. We need 4 students to be chosen for the first 4 presentations. 1, 2, 5, 6, 6, 4, 0, going backwards, 1 million different ways, 1,256,640 different ways just for the first 4 presentations. Anyway, think about that. Think about that in your mind. I think it's just fascinating. Okay, here we go. How many distinct, this one, I had to look up, and I'm still not satisfied with the math behind the counting. I'm still just not. Okay? I want you to see this, though, so that it's clear and in your brain. Whoops. Well, that didn't work. Okay. We are now in chapter 3. We are on permutations. We need to talk about with like objects if we want unique. Okay. It's NPN over P factorial or Q factorial if something is repeated that many times. That seems very obscure, so let's go talk about it in a concrete example. Question 5 with the word cheer. Okay, so what's happening here, we have our formula NPN over Q factorial or P factorial. They're just saying whatever's repeated. So we only have one letter that's repeated, but there's 2 of them. So we would do, there's 1, 2, 3, 4, 5, 5 P5 over 2 factorial because it's repeated twice. E is repeated twice. So let's go up here. Let's do that. Let's just hit enter. Let's go to functions. 5, 5 divided by 2 factorial 60. Okay, 60. but that's what's happening. That's the math behind it. I'm not convinced. I've still messed with it. I'm going to take a smaller sample and I'm going to use colors. So you'll see that. You'll see it next. Combinations is next. It's a little bit different than permutations. So thanks for watching. Thanks for thinking. And I'll get you that video as soon as I can. Okay?